All right, we're talking about points of intersection. This is where the two graphs intersect and they have a common point. Let's look at some examples. All right, so I've got y is equal to negative x plus 5 and y is equal to x. Now this point right here is the point of interest. This is the ordered pair that we want to find. This is where the x and the y coordinate are the same. And so in other words, if both of the y values are the same, then that means that if this y is equal to this y, then what I can do here is set both of these equal to each other. So I'm going to do that, and what we're going to end up doing here is we're going to end up finding what this x is right here. So I set these both equal to each other, and I solve for x in this problem. And what I'm going to do here is I'm going to take this over to this side. You can think of it as adding x to both sides. I just think of it as moving it like a chess piece. And the reason I'm moving this x over here because there's a negative out front. So we end up having x plus x, or 2x. Right, that's all equal to 5. So then we multiply both sides by a half or divide by 2, however you want to look at it. And so we end up getting x is equal to 5 halves, right? So we do this, and we end up getting x is equal to 5 halves. So this is 5 halves. Now, to figure out what y is, right, we need to find out what that is. You can take this 5 halves and you can either plug it into this one, or you can plug it into the y is equal to x. Well, obviously, if I plug it into the y is equal to x right here, y is going to be 5 halves. So that's pretty simple. If I plugged 5 halves in up here, this should be 5 halves. If it didn't, then we did something wrong. But as you can see here, y is also 5 halves. So this point of intersection here, we're going to write it as an ordered pair, is 5 halves, 5 halves. All right, let's look at another example. Okay, so we have this parabola, and then we have a constant, y is equal to 5. And so what we're going to do is I'm going to just set these both equal to each other. So x squared is equal to 5. Okay, and we square root both sides. And of course, this is plus or minus. So when we square root, remember we got to put a plus or minus here. So our x is going to be the square root of 5 and negative square root of 5. Okay, and to figure out what our y value is going to be up here, well, that should be pretty obvious because y is equal to 5, which is a constant, right? Every point along this line right here has to be 5. Therefore, right, this ordered pair right here is going to be the square root of 5 comma 5. And then this one over here would be negative square roots of 5 comma 5. Hey, looking at another example. Okay, so we've got this parabola here, and then we've got a straight line, y is equal to x. So remember, we set both these equal to each other, and then we solve for x. So these are some real simple examples, but you would follow, no matter how hard these equations are, you'd follow the same procedures. So I'm going to do here is factor an x out. And then solve for x. So we said both these factors equal to 0. Well, this one, you set it equal to 0 and you're done, right? There's nothing else you can do with that. And that corresponds to this point right here. This is where x is 0. Now you set this other factor equal to 0. And I guess I'll just do that right here. And you solve for x, bringing the 1 over, making a positive 1. So therefore x is equal to 1. Now, let me guess. I'd almost bet that that must be that right there. Okay. But how do we find out what the y value is? Well, you can take this 1 and plug it into either this one or this one. It doesn't make any difference. You should get the same y value out. And of course, if I plug it into that, well, that means y is 1. Or plug it into this one here, y 1 squared is 1, right? So as you can see here, this ordered pair, this is the point of intersection, and it's 1, 1. And this point of intersection here is 0, 0.